Alright, so first experiment that we're going to be conducting is the jar test experiment. So what apparatus do we need? So basically we would need 6 different beakers or a jar for each coagulant. We need our syringes, we need the jar test apparatus machine, we obviously need our water sample. For the procedure part, first we add 1000 milliliter of water sample into all of our beakers. So as you can see here, make sure to also label each jar. So 1 would be our blank sample, and 2, 3, 4, 5, and 6. Okay, next we're gonna add our coagulants into our beakers. So the coagulants that we're using is alum and ferric chloride. So we're adding 2 different coagulants, and each beaker we're going to add different volumes of coagulant to determine the optimum dosage of coagulant. Okay. We're going to be adding 2 milliliter of coagulant, 4, 6, 8 and 10. Okay, once all the coagulants are added into our beakers, we place each of our beakers under the propellers of the jar test apparatus. So first we're going to set the timer to 3 minutes, and we're going to drop our propellers into the beaker. Make sure it doesn't touch the bottom of the beaker. So first we're gonna do something called rapid mixing. So rapid mixing is 140 rotation per minute for the speed, and we're gonna do it for 3 minutes. So after 3 minutes and the rapid mixing is all done, we're gonna set the speed to 70 rotation per minute, and we're gonna do it for 5 minutes. So as you can see, the flocks are starting to form during the slow mixing. You can tell the more coagulants added, the more flocks. You can see the blank sample has no flocks, has very minimal flock. So after 5 minutes, you just let all the beakers, we let it rest for 15 minutes. That is to let it settle. As you can see, different dosage of coagulants produce different flocks.
From the jar test, after we let it rest for 15 minutes, we can check for the turbidity using the turbidity meter, and then we take 10 milliliter of water sample that we add the coagulant, and then add into this cylinder sample. You can see here for the 10 milliliter, and then we repeat for alum and ferric coagulant for each volume of different kind into the water sample, and then we put into the turbidity meter. After we put the 10 ml of our water sample with different volume of coagulant, we can check for the turbidity using the turbidity meter.
Okay, first we turn on the power button.
With the 10 ml of our cylinder sample, we wipe it clean of any fingerprint or any residue.
And then we press the seat leverage. After that,
rage button, and then we can take the reading. Once the reading has stable, we can take the reading. Okay, after that we can proceed to all the water sample.
Okay, from the jet test, we can also measure the pH level for each of the sample with different coagulant. So we will transfer the sample into a smaller beaker. So we will take 100 ml for each sample. And then we will repeat for all the samples. To measure the pH, first we will use the pH meter. First we will turn on the pH meter. Then we will rinse the tip of the probe with the water. And then we will put the pH probe into the water sample. Now we will wait for the meter to read the pH level. After the reading is stable, the log sign will appear on the screen, and then we can take the reading of the pH level.
We take for the blank sample, and then we take 10 milliliter from our water sample into this square bottle. So we can use this rectal photometer to check for suspended solid. First of all, we wipe this bottle of our blank sample and then we put it in our bag. And then we close the cover and then we use this. After that, we put our first sample inside of here and then we cover it and then we read the suspended solid.
From this table, we can see that a different coagulant and dosage results in different value of turbidity. From the graph, we can see that the optimal dosage for aluminium sulfate is 4 ml, where the turbidity is 4.45 NTU. For ferric chloride, the optimal dosage is 10 ml, where the turbidity value is 2.12 NTU. This table shows the pH value of the water sample after treatment. As we can see here, both of the coagulant reduce the pH level, but ferric chloride reduce the pH level more than aluminium sulfate. Based on graph, at 10 ml dosage, ferric chloride pushed the pH down to 4.07, while aluminium sulfate only reduced the pH to 5.52. We measured the total suspended solid from the raw water sample. The reading is 61 mg per liter. This high value confirms that the water sample is quite dirty, which is why effective coagulation is so important to the treatment process.